Hi guys, you are at the point of your lesson where you are ready to take some notes. The notes that I'm going to show you are an already filled in version of what you have, so it would be the same as if you were looking on Haiku. And so I'm just going to talk you through a couple of those things, and hopefully this will settle in. I think the nice part about this lesson is that it is what I would consider a little bit of a break. I think you guys have had some really hard lessons and some really difficult skills that you guys have been working on, and I hope that today you find that this one isn't quite as challenging. If you look at the title, it says arithmetic operations, which means we're going to be adding, subtracting, multiplying, and dividing today. Those are things you've been doing for a while. So I hope that this will go smoothly for you guys and you'll be able to grasp it just with this video. So let's dive in. In that circle, I guess it's not a circle, I should use the correct term, the ellipse on your notes. You see that complex numbers are split into two different sections. You have real numbers and you have imaginary numbers. And that's going to come into play when we talk about how they're supposed to be written and what the proper form is. So you can see real numbers are rational and irrational numbers. Rational numbers are numbers that can be written as fractions, and irrational numbers are numbers that cannot be written as fractions. You're not overly familiar with, I would say, that many irrational numbers. You can see in that category there's the square root of 2, and then there's also pi. A lot of square roots that aren't perfect fall into the irrational category, and that's typically what stays there. On the other side, they have imaginary numbers. If you look at the two on the top, 3i and negative 2i over 3, those both have i's, imaginary number. I'm sure that's why they picked i's. Typically people write them with what looks like a cursive I. That's up to you, cursive, lowercase, whatever you want to write it as. The one underneath is different. The square root of negative 56 is actually considered an imaginary number. If you have your calculators out, you can plug that in. Go ahead and try and do it. If you try to take the square root of negative 56, you can try that, and on your calculators, depending on what kind of calculator it is and what kind of answer it'll give you, it's going to give you some sort of error message, or it's going to say not possible, or domain error, something like that. You're not able to take the square root of negatives. I hope that you guys know why. So if you think about, like, let's take a different number, square root of 16. Well, if I ask you square root of 16, I am guessing most of you are answering 4. The reason it works is because 4 times 4 gets you 16. So what you're doing is multiplying a number by itself. Well, if you're multiplying a number by itself, you're either going to be multiplying a positive times a positive or a negative times a negative. In that case, are you ever going to be able to get a negative number? Well, no, because two positives are positive and two negatives are positive when you multiply. And so you're just not going to be able to get a negative number, and then that in comes imaginary numbers. So the square root of negative 56 is imaginary. By the end of the lesson today, you will be refreshed in how to simplify that, which is a concept that I think that you should have already studied. So again, I hope this lesson goes well for you guys, because it should be, or should feel like, a little bit of review. All right, so definition of complex numbers. This is why we just talked about it. How all of your answers should be written today is A plus BI. A is the real part. BI is your imaginary part. So you need to know that. They should all look that way. Every time we see an I in your answer, I is equal to the square root of negative 1. So if you have a square root of negative 1, you're going to take it out, replace it with I. So in no place in any of your answers should there ever be a negative square root. Negative square roots, they get pulled out and they get replaced with I's. All right, so let's jump into adding and subtracting. To add and subtract, you're going to combine the real parts and combine the imaginary parts. If you want to simplify it down, you can almost actually think of I as a variable. And so you can also think about it as you're going to be adding or subtracting like terms. It's that simple. You guys have added and subtracted like terms before. It shouldn't be a surprise to you. So when you go ahead and look at this setup, negative 2 plus 3, those are your real parts, gets you 1. 4i plus negative 11i, and you're going to get that negative 7i. Again, your answer is in the correct form. You have your real part first, and then you have your imaginary part. Number 5 is subtraction. I'm assuming you were taught to do this. If not, you don't have to, but I would recommend it. My recommendation is to take that subtraction sign and distribute it. It just decreases on the chances that you're going to make an error. So this would become a -5 and a -8i. So if you look over here, that's what's written. 4 minus I minus 5 minus 8i. Again, real parts go together, -1. Imaginary parts go together, -9i. Then we make things interesting and we put 3 terms there. Shouldn't throw you for a loop. So again, I would take this negative or this subtraction sign and distribute it, a +6, a +9. Take this negative sign and distribute it, -2, -i. It's going to help you in the long run if you distribute the subtraction signs. I promise it will help. So then go through -5, 6, and -2. That gets you a -1. 4i, 9i, and -i. Remember, there's a 1 in front of that I. So 4 plus 9 is going to get you that 13. And then that 13 minus 1 gets you 12i. And again, your answer is real first, -1, imaginary 12i second. Okay? Multiplying complex numbers. Multiplying complex numbers by using the distributive property and treating imaginary parts as like terms. It's kind of what I was just saying, right? You can still multiply. You treat them as if they were variables. You do the work. Just so you can see what's going on here, it always replaces the square root of -1. You're going to use that one a lot. The other one you need to have memorized is I squared. I squared gets replaced with -1. So again, just like you can't have a square root of a negative in your answers, you got to replace that. Same thing if you have an I squared, you have to replace that with a -1. There's some other ones here, and there's a pattern here. For now, because I'm not there, we're just not going to worry about it too much. It won't be a thing. If you want to talk about it later with me, I can go over it with you. Let's dive into the multiplication. So first one, as you're looking at this, I hope that you recognize that this is distribution. So it's 2i times 3. No, the 3 doesn't have an I, but it doesn't matter. You're still allowed to multiply it. You can't add them, right? Those rules are different, but you are allowed to multiply them. 2i times 3 gets you 6i. Now you do the second part. 2i times a -5i. Negative 2 times 5 gives you 10. I times I gets you I squared. So 6i minus 10i squared. Some of you might think you're done, but you're not. Remember that every time you see an I squared needs to get replaced with -1. So now this is a -10 times a -1. That becomes a +10. 10 is no longer imaginary, so now 10 needs to go into the front of your answer. 10 plus 6i. 10 is your real, 6i is your imaginary. So your answer has to be 10 plus 6i. Distribution. Letter B is foiling, distribution. You could do a box. Whatever method you want to do with this, go for it. I just distributed. So -6 times 5, -30. -6 times -4i. 2 negatives make that a positive, so 24i. 3i times 5, 15i. 3i times -4i, -12i squared. Catch that. That's a -12i squared. Okay. You're done with multiplication. Now you're back into the adding rules. 24i and 15i are like terms. Those are going to get you a 39i. -12, the I squared gets replaced with a -1. So -12 times -1 is a +12. Notice now 12 again became real. It's not imaginary anymore. And you have a -30, which is also real. So -30 plus 12 gets you that -18 plus 39i. Okay, so multiplication. You can multiply anything you want. They work just like variables, so I times I is I squared, and all I squareds have to be replaced with a -1 and simplified. You don't get to leave them. All right, last part. We've got some work to do to get to dividing. So -7 Let me try that again. Negative 11 plus 37i has a complex conjugate of negative 11 minus 37i. 3 minus 8i, the conjugate is 3 plus 8i. 9i, the conjugate is negative 9i. So you're looking at three different sets of, and the word that you're using is conjugates. So you have three sets of conjugates. My question to you is, how would you explain how to create the conjugate? What would you be doing? What is the change that happens between 11 plus 37i and negative 11 minus 37i? I hope you are realizing, and this is what you need to fill in. To find a complex conjugate, change the sign of the imaginary part. Change the sign of the imaginary part. So here's an example of why we do this. 3 plus 4i, 3 minus 4i. Those are conjugates, right? A positive imaginary part and a negative imaginary part. So again, you're going to distribute like we did before. 3 times 3 is 9. 3 times negative 4i is negative 12i. 4i times 3 is 12i. And then 4i times negative 4i is a negative 16i squared. Look at your like terms in the middle. Negative 12i plus 12i, that becomes 0. All of the i's in the middle cancel out. I squared is going to get replaced with a negative 1, so that becomes a plus 16, and you get a 25. You don't have any imaginary. That's what a conjugate does. That is the point of a conjugate, to get rid of the imaginaries every single time. So, although we're in the dividing part of the lesson, you're not actually doing any division. Well, you might at the end when you reduce. But for the most part, you're not doing any division. What you're doing is called rationalizing the denominator. You're getting the imaginaries out of the bottom. So, here's your example. 3 minus 5i over 2 plus 6i. You are not allowed to have i's in the bottom, in your denominator. That's not allowed. So you multiply top and bottom by the conjugate. So you're going to multiply the top by 2 minus 6i and the bottom by 2 minus 6i. Yes, this is a lot of work. Yes, do the work. You can handle it. Remember, on the bottom, you should end up with a whole number. No imaginary, you should end up with a real number. Okay? So here we go. On the top, 3 times 2, 6. 3 times negative 6, negative 18. Negative 5 times 2, negative 10. Negative 5 times negative 6, positive 30i squared. Replace the I squared with a negative 1. Becomes negative 30. 6 minus 30, negative 24 minus 28i. That's the top. The bottom conjugates. The middle terms cancel out. Positive 12i, negative 12i, those are gone. Negative 36i squared. So that becomes a positive 36. And 4 plus 36 is 40. Now put your answer back together. So the top, negative 24 minus 28i. The bottom is 40. All right, so what I did from here to here is reduced it. 24, 28, and 40. What number can come out of all three of those? And you can reduce it by 4. All three parts can get reduced by 4. If you don't like doing them all at once, split them up into separate fractions, which you do have to do eventually, because you notice the 6/10 becomes 3/5, and that's more reduced than leaving it this way. So you do need to divide them up and reduce them both separately. All right. Here is, well, you've got it in your notes, example number 9. I want you guys to take a minute and work on it, set it up. So do top, bottom, and then put it back together. And I will give you the answers and an explanation on the next video.